Hello, in this video we're going to take a look at midpoints. So if we have 2 points, the midpoint is going to be the point halfway in between them. And so for 2 points x1, y1, x2, y2, our midpoint is going to be the average of those x values. So we're going to add up the x values and divide by 2, and then do the same thing for the y values, and that will give us the coordinates of our midpoint. All right, so if we wanted to do the midpoint of the line segment from the point 2, -5 to the point 4, 7, we're going to take those 2 x values and average them, add them up, divide by 2, and do the same thing for our y values. Since we're adding them, it does not matter what order we list them in, as long as we use both x values to find our x coordinate and both of the y values to find our y coordinate. All right, simplifying this, 2 plus 4 gives us 6, divided by 2 is 3, is going to be our x coordinate, and then -5 plus 7 is going to be a 2, divided by 2 is 1. So the midpoint is the point 3, 1. All right, if we want to find the midpoint of the line segment from HK to the origin, we're going to have h plus 0 over 2 and k plus 0 over 2, and that's going to simplify to h over 2, k over 2. And without knowing what h and k are, that is going to be as simple as we can go. All right, so now let's look at another one that's going to be a little bit more of a distance. We want to find all the points that are on the x-axis that are 16 units from the point 5, -8. So let's just kind of draw a picture to see what we're talking about here. So the point 5, -8 is going to be in quadrant 4, and we want to find all of the points on the x-axis that are 16 units from that value. And so I don't really know where it is, but I'm expecting there to be one over here on the negative side of the x-axis, and then we'll probably have one over here on the positive side of the x-axis where we have 16 is going to be the distance on each of those. We do know what the midpoint is between those 2 points, though that's not going to help us a whole lot in answering this question. But if it is on the x-axis, remember, it's always going to have a y value of 0. So we're looking for a point that is in the form of x, 0. And we want it to be 16 units from this point. Remember, our distance formula is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So our x2, we'll go ahead and call this x.1 that we're looking for, and then the 5, -8 is our point 2. So we'll get -8 minus, our x value here is going to be 5 minus x quantity squared, and then our y values are going to be -8 minus 0 quantity squared, and we want that distance to be 16. All right. So 16 squared is 256, so we can get rid of that square root. 5 minus x, can't do anything with that just yet. -8 minus 0 is -8. Squared is going to be 64, and we can subtract that from both sides. Let's see, 256 minus 64 is equal to 192. We want to solve this for x. This is a quadratic equation that's set up very nicely for the square root property. When we take the square root, remember we have to have plus or minus. And so square root of 192, let's see, 192, we can simplify that square root. I know 4 goes into it 48 times, and 48 is 4 times 12, 4 is 2 times 2, 12 is 3 times 4, 2 times 2, so we've got 1, 2, 3, 4, 5, 6. 2 to the 6 times 3 would be that prime factorization. And so 2 to the 6th is a perfect square. When we take the square root of that, we're going to get 2 to the 3rd, which is 8. And then still have a 3 underneath the square root. It's going to leave us with 5 minus x. And then we can subtract 5. Negative 5 plus or minus 8 square roots of 3 equals negative x. And then divide everything by a negative 1 gives us 5 plus or minus negative. It's going to make that a positive. Plus or minus divided by negative, still going to have plus or minus there. And so we get that those two possibilities are going to be, this one's going to be at 5 plus 8 square roots of 3, 0. And this point is going to be at 5 minus 8 square roots of 3, 0. All right, I'll see you guys next time.